Hey, hi YouTube. I hope you all guys are doing great. In this video, we are going to see two memory types. First one is conversation buffer window memory, and second one is entity memory. Actually, I have combined both the topics because the conversation buffer window memory is very small topic. It's like extension of conversation buffer memory, which we have covered in the previous video. If you have not watched the conversation buffer memory video, just watch it because the difference between conversation buffer memory and conversation buffer window memory is just a one parameter difference. So you should know about conversation buffer memory. And in case if you don't know, this whole video is a part of a playlist which is about memory in Langchain. So if you access this playlist, I guarantee you that you will be good enough in the topic of memory in Langchain, and you can also have a good practical implementation of memory in Langchain, so that whenever you will create a RAG chatbot or LM chatbot, wherever memory will be used, then you can have a good knowledge of how to implement memory in Langchain. So let's start with conversation buffer window memory. Just to revise you the conversation buffer memory, in conversation buffer memory, all the conversation was getting stored. Let's suppose you have two conversation, it will be stored as intact in the memory. If you are having 10 conversation, the same 10 conversation will be stored in the memory. So what's the problem in this approach was the resource consumption approach, because the resource consumption problem, because when you store all the chat in the memory as it is, so it will consume much more memory, and also it will consume much more resources. So in conversation buffer window memory, this is how you use it, like from langchain.memory import conversation buffer window memory. So in conversation buffer window memory, it keeps a list of the interaction of conversation over the time. It uses only the last k interactions. This is very important. This can be useful for keeping a sliding window of the most recent interactions, so the buffer does not get too large. Okay. In conversation buffer memory, it was storing all the chats, but in conversation buffer window, it stored the last k chats. Okay, the value of k can be 2 or 3, we will see. Okay, so first of all, let's see how we use it. This is how we initialize a memory, conversation buffer window memory, and we have to pass the value of k. What is k? K is basically the last k messages. Like if in the memory you want to store the last two messages, so the k value will be 2. If you want to store 3 messages, it will be k is equals to 3. If you want to store n messages, it will be k is equals to n. Now memory.save context. So to save a chat, like we are saving input hi, output whatsapp, and here it is memory.load memory variables, just to see what are the memory variables present. So in history, which is a key, basically the memory is in a dictionary format, and the history or the memory is human saying hi and AI is saying what's up. Okay, now memory.save context, not much you, output not much. And again, if you load the variables, now this part human hi AI whatsapp is gone, because we have to just store the last k interactions. The value of k is 1, so the last one interaction, this is this one. So that's why this one, which is human hi AI whatsapp, has been vaporized, and here it is like human not much you, AI not much. Okay, then what you this is it, I guess. This is just the repetitive one. Okay, so I have just repeated these two cells, so let me just delete it. Okay, so this was it. Okay, now let's see how we can use conversation buffer window in chain. So I'm using Hugging Face API token, so you can also use it. It's very quite free. Why we are using Hugging Face API tokens and Hugging Face models? Because it's free. Okay, if you don't know about Hugging Face, it's a GitHub for models. Okay, where you can upload your model, or a lot of LLM models, SLM models are there. So we are going to use it. If you have an OpenAI key, well enough, because OpenAI key needs some investment. So if you don't have an OpenAI key, that's fine, you can use open source models. So we are going to use a conversation chain because we are going to have conversation. This is for Hugging Face. If you are following me in this playlist, then I think you know all these things. Then OS and then config, because we have put our Hugging Face API token and OpenAI API token in this config.py. Then we are creating a memory where the value of k is 2 and it is conversation buffer window memory, so the last two interactions will be memorized. Then we are using this Hugging Face model, verbose true, because we want to see what is actually happening under the hood, and we are passing the memory, which is memory is 2. Okay, now if you ask a question like tell me about solar system, so here it is, this is what verbose is equals to true, because we want to see what is actually happening under the hood. So there is a prompt, which is the base prompt. Okay, we are not passing a prompt here, but also you can pass a prompt if you have a customized or modified prompt, but I want to go with the system prompt only. Now the input is tell about solar system. History, in history there is nothing, then the answer is there. Now I am again asking a question, how many planets are there? So here you can see in history there are two questions now. First one is tell me about solar system. Sorry, one question, which is the previous question, tell me about solar system, and the solar system is the region of space containing the planets. Okay. Now if I ask another question, is there any other like this exist? Okay, so here you can see like in the history there is human, tell about solar system, AI, the solar system is the region of space containing the planets, moon, and this and this. And then the next question, how many planets are there? And there are 8 planets. Okay, now if I ask another question, name other like this, then here you can see in the history section, because input and output I don't want to explain, just see the history section. Here it is, how many planets are there, and if you just remember, then how many planets are there was the second question, not the first question. So the first question has been vaporized from the memory now. Why? Because we just want the last two interaction, and for this question, which was the last two interactions, is there any other like this exist, and how many planets are there? So that's why the first question or the first conversation in the memory is the how many planets are there. So the very basic difference between conversation buffer memory and conversation buffer window memory is the value of k. So the k is the last, or you can say how many conversation I have to remember or I have to memorize. So that's it. So it can be helpful in some case, but if you want to have long context, like let's suppose sometimes if you are using ChatGPT and you ask some questions which you have asked like 3 to 4 questions before, in this case if you have set the value of k as 2 or 3, it may fail. So it depends upon if you are having a long context conversation or something else. So it depends upon use case to use case. If you understand it, definitely you can use it in several way. Okay, wherever you need it. Okay, so this was about conversation buffer window memory, and now let's see some other memory which is more interesting one, which is entity memory. Okay, so entity memory is like it remembers given facts about specific entities in a conversation. It extracts information on entities using an LLM and builds up its knowledge about that entity over the time, also using an LLM. Okay, LLM plays a very crucial role in this entity identification. So to make it much easier, I can like let me show you something first, and then I can explain much more. Okay, so if you want to use conversation entity memory, so here you can import it, langchain.memory, import conversation entity memory. We are going to use our chat OpenAI because why I am using it, because I experimented this memory with Hugging Face models like Google 25XXL. I also use GPT-2, which is an open source model hosted on Hugging Face. I have used some Mistral models and some other some models from Microsoft also. So I don't know whether it was from Microsoft or not. I don't remember, but all these models were like good models. So I used this LLM, but they were not giving the answer that I wanted. So definitely I have to shift to this chat OpenAI. But definitely there will be some models you can find it. If you find that open source model, please post in the comments so that other can also use it, those who don't have a OpenAI key. Now we are using the chat OpenAI key, import and config, and we are going to use this model GPT 3.5 Turbo 0613. So I think you know how to use it, like LLM OpenAI, chat OpenAI, and we have to pass OpenAI key and then the model name and some model quarks if you want to set the temperature and the hyperparameters. Okay, now we have created a memory is equals to conversation entity memory, and here also you have to pass a LLM. Okay, this is what the syntax of conversation entity memory is. Now if I ask, give a question, user input, Devon and Sam are working on hackathon project, then if you do like memory.load memory variables user input, so it currently you can see there is nothing in history, but it has identified some entities like Devon and Sam. Okay, now if I like do like memory.save context, and I'm giving the user input also as the output, like the output will is like, that sounds great, like a great project, what kind of project they are working on. Then if you do memory.load memory variables again with this input, who is Sam. Now here you can see in the history there are two things, like first one, this input Devon and Sam. So here you can see Devon and Sam are working in a hackathon project, and then the AI message that sounds like great, like we have added it. Then the input is like, who is Sam. So every time you do load memory variables in the previous memory, if you see like in buffer window memory also, you can just do it like memory.load memory variables, but in case of entity memory you have to pass some input. So that's why we are passing some input like who is Sam. Now the entities have paired, like Sam entity is now related with Sam is currently working on a hackathon project with Devon. Okay, so this is how entity memory works. Okay, let me simplify it. Like entity memory is like a brain that remembers a specific fact about things, which is called as entities in our conversation. It uses a powerful language model, which is LLM, to understand and remembers these facts over time. So like here also you can see we have created a instance of conversation entity memory class, which will help us to remember information about the entities. Then loading the memory, so we loaded information info memory. For example, if we say Devon and Sam are working on a hackathon project, the memory will be first, the memory will remember this first fact. Okay, then we are saving the context. So we save context based on the input. For example, when we say the above statement, the response might, that sounds like a great project, what kind of project are they working on. This context is saved in memory. Now querying the memory, so this is how we query the memory. So when we ask a question like who is Sam, the memory retrieves the relevant information from its stored facts. It knows that Sam is working on a hackathon project with Devon based on the earlier input. So this is how it works. Okay, now you might have confused, like when we have to use this dot load memory variables, and when we have to use this dot save context. Okay, so let me simplify it. First let's talk about this load memory variables. This function is used to retrieve information from the memory. It looks at recent conversation history and extract any named entities like people name, place, or else others mentioned in the conversation. It also provides summaries for these entities if available in the memory. Then if you talk about save context, this function is used to update the memory with new information. It takes the current conversation context input or output and saves the summary of entities mentioned on the conversation. It uses a LLM chain to generate summaries or entity based on the conversation context and saves this summaries to the memory. So in simpler terms, load memory variables help you see what stored in the memory, while save context helps you to update the memory. Okay, so in save context we are updating the memory, but in load memory variables we are able to see what is actually stored. Okay, by generating and saving summaries for entities mentioned in the conversation. Okay, and still if you want to study more about this, just do control and click, and here you can see something like this one, load memory variable. So here you can see how actually they are loading, and you can also read the comments, so then you can have a better clarity between save context and load memory variables. As of now, I can just say load memory variables help to see what is actually stored in the memory, and save context helps to update the memory, okay, with new information. Okay, so now let's see some challenging part, like how we can use it with chain. Okay, so here I'm using basically again I'll the same chat OpenAI models. So initially I have initialized the models here, so that's why I'm not initializing it again. So we are using conversation chain because we want a conversation, then we want conversation entity memory, and then we also want a prompt. Okay, I will explain. Okay, then this all things are not needed, so just let me remove it. I don't know why I have added it. Then conversation is equals to conversation chain. LLM is LLM OpenAI, verbose true because we want to see what is actually happening under the hood. And in the prompt we are passing entity prompt conversational template. Okay, I will show you what the template is. It's already in the langchain.memory.prompt package. Then memory is equals to conversation entity memory, and as I have told you that this memory also needs an LLM, which is in our case we are using LLM OpenAI. Let me show how this conversation chain looks like. So I have printed this conversation. Okay, and which is very important part, like I want to show the prompt of this conversation chain, which is this entity memory conversation template. So in this prompt you can see it takes three input variables: entities, history, and input. And just let's go through this prompt like you are an assistant
to a human powered by large language model trained by OpenAI. You are designed to be able to assist with a wide range of tasks, from answering simple questions to providing in-depth explanation and discussions on a wide range of topics. As your language model, you are able to generate human-like text based on the input you receive, allowing you to engage in natural sounding conversation and
so on. Okay, you can read it. And then first of all, we are in the context part, we are sending the entities, and in the history is adding into the current conversation, and the input is like what actually question we are passing. So this is what I want to show you. Now let's see the magic. Like I'm asking conversation.invoke, input is Devon and Sam are working on a hackathon project. So first one, it was entities. So let's see how, that's why we have done verbose is equals to true. So here you can see in context it identified the entities, because here you can see the entities, let me just show it. The entities were in the context part, the history was in conversation, current conversation part, and the input was in the human input, that human gave the input. Okay, so here in this Devon and Sam are working on a hackathon project. So here you can see the context they are having is Devon and Sam, because it has it has identified two entities which can be useful, and current conversation, there is no conversation in the previous conversation, and then last line is like last line from human. So this is the input part. Okay, we have seen in the prompt. So Devon and Sam are working on a hackathon project, and if you see input, history is blank, entities we have extracted, and response is like, that sounds exciting. Hackathons are a great way to collaborate and work on innovative projects. Can you tell me more about what Devon and Sam are working on for their hackathon project? Okay, now let's see how we can actually see which kind of entity has been stored. So you can do like conversation.memory.entity-store.store. So here you can see in Devon, like they have stored, they have mapped with that Devon entity that Devon is working on a hackathon project with Sam, and Sam they have mapped like Sam is currently working on a hackathon project with Devon. So this is how the entity store looks like. Okay, now if we ask another question, conversation.invoke, they are trying to add more complex memory structures to Langchain. Now here you can see that in context they have again identified some entities. So the entities are like Langchain and Devon, which already is there, like Devon is working for a hackathon project with Sam, which we have seen here. Sam is currently working on a hackathon project with Devon, so here it is. But a new entity has been added, which is Langchain. Okay, because we have just identified some entity which is Langchain. Now current conversation, it will be the previous conversation. The previous conversation was Devon and Sam are working on a hackathon project, and this was the output. So here you can see question and output. The last line, what human has asked was, they are trying to add more complex memory structures to Langchain. So here it is. So now you can see there is input, there is also history, the previous conversation, some more entities like Langchain has been added, Devon and Sam were already there, and the response is like, that's interesting. Adding more complex memory structures to Langchain sounds like challenging and ambitious goal. I don't want to read all things. Okay, then again we are asking another question, like they are adding in a key value store for entities mentioned so far in the conversation. Okay, so now here you can see in current conversation, like here you can see the context is gone, but the current conversation is like the whole two messages, the whole two previous messages. In the context of Langchain, it's like, okay, so here the human question is also there, like they are adding in a key value pair or something like that. Okay, I think they have not identified any entities, but the history is there from starting to till now. Okay, and now the answer is like, that's an interesting addition. Adding a key value stored for entities mentioned so far in the conversation can provide a convenient way to store something like that. Now if you ask another question, conversation.invoke, and you add, what do you know about Devon and Sam? Now in the context, it identified two of the what you can say entities, which is Devon and Sam. And in the current conversation, we are having human AI. So Devon and Sam are working on a hackathon project, and they are trying to build more complex structures, and Langchain are there. Okay, and if you see the output, like, what do you know about Devon and Sam? So human, this was the question, and this was the whole history which was that has been placed. And in entities, we are seeing Devon and Sam, and responses like, as an AI language model, I don't have access to perform information about individual unless it's shared in the conversation. Now let's see, like, we can also inspect the memory store directly, where all the entities have been stored. That is called memory store. In the following examples, we'll look at it directly and then go through some examples of editing information and watch it how it changes. So I don't want to show the changes, you can just watch it. But here we have already created a memory which was which we were storing in this entity store. Okay, so conversation.memory.entity.store. So here you can see, like, first key was Devon, and we have stored like Devon is working on a hackathon project with Sam, and the goal is to add more complex memory structures to Langchain. It has combined the two input. Then Devon and Sam. So Devon and Sam are individually involved in the hackathon project for Langchain, and they are adding key value store entities mentioned and contextual capabilities for the language. Then if you see the Langchain key, so it is also telling something about Langchain that we have already saw in this prompt. And then we are having Sam, which is currently working on a hackathon project with Devon, and so on. So this is how you can also watch the entity store, and definitely you should use a powerful LLM model. Now where it can be useful, like the conversation entity memory can be useful in a lot of scenarios where you want your AI system to remember and understood specific details, okay, about entities such as people, places, objects mentioned in a conversation. So let me give you some scenarios where you might use it. Like, first is personal assistant. For personal assistant application, the memory can store information about the user preferences, daily routines, important events. So for example, remembering the user name friend is named Sam, and they are working on a project together. Okay. Then customer support. In customer support applications, the memory can store information about customer inquiries and interactions. For example, remembering details about a customer previous questions or issues. Then the knowledge base, like in a chatbot or virtual assistant that provides information for answer questions. The memory can store important information about the topics discussed in the conversation. For example, like remembering details about a specific product or a service. Then contextual conversation, like in general, this CEM can be used to maintain context in conversation. For example, in a role-playing game, the memory can remember details about the player interactions with characters and events in the game world. Then it can be also helpful in like interactive storytelling. Like in interactive storytelling applications, like the memory can store information about the baby plot and character, allowing the story to evolve based on their users choice and actions. So I can say overall conversation entity memory is useful in scenarios where you want your AI system to have more contextually aware and personalized interaction with users, so based on the entities mentioned in the conversation. So this was it about the conversation entity entity memory. So if you have any doubt, you can ask in the comment section. Definitely, I know it sometimes it sounds very not tough, but I can say a bit confusing. So keep going and keep experimenting, print each step do verb true. So if you print each step, you can basically learn like how actually this prompt is coming, what is actually inside the prompt, how I can modify it, which kind of variables it's taking. So play with it, you can definitely understand it. So that's it from this video from my side. If you like this video, please like, comment, share and subscribe, and I hope I will meet you in the next video with some more types of memory. Till then, bye bye, thank you.